All right, it looks like we've studied at the number of participants right now, so I'm gonna get started. Okay, so welcome to today's CNCF webinar, To Russia with Love, Kubernetes in Exotic Locations. You know, I saw this title in the list of webinars that are coming up and I was like, I must moderate that one. It's just so cool. Anyway, so I'm Priyanka Sharma and I'm an ambassador for the CNCF. I'm also a governing board member and I am director of Cloud Native at GitLab. And I'll be moderating today's webinar. So thank you so much to everyone who is joining today. I'd like to welcome our presenter for the day, Michael, gosh, I'm gonna do my best with the last name here, Michael Wojcikiewicz. Sorry, Michael W., who is a container solutions architect at CloudOps. So just before we get going though, a couple of housekeeping items. During the webinar, you won't be able to talk as an attendee. This is kind of going to be like a broadcast feeling. But the good news is you can, there's a QA box at the bottom of your screen. If anybody has trouble seeing it, please put a note in the chat and I'll try to help you out. But it's Q&A is there right next to participants. And when you want, you can drop your questions in there. And then towards the end, when Michael is done with his presentation, I'll go through the list and we'll get through as many as we can. And if there's some questions that we weren't able to answer because of time or whatever reason, Michael's contact will be at the end of his presentation and you're able to get direct responses from him as well. Just so everybody knows, this session is being recorded and we will send out a link afterwards along with the presentation. So with all of those good things said and done, I would like to hand it over to Michael to kick off today's presentation. Over to you, Michael.
Thanks, Priyanka. So welcome everybody. Good morning, good afternoon, good evening, wherever you're from in the world. This is the talk of To Russia with Love, Kubernetes in Exotic Locations. If you came here looking for To Russia with Love and you're a rancher trying to get beef into Russia, this is not the talk. And this is me doing some SEO searching right before the talk and realized that, oh, maybe people won't be able to find the talk so easily. But you're definitely at the right talk if you're here to learn about how to run Kubernetes on premises. So the agenda today, I'll do a bit of an intro about myself and the company I work for, CloudOps, and some CNCF info. We'll talk about the story so far, how we got to be where we are with the client, and where we needed to go to because of international data laws and things like that. So I'll talk about some of the technical problems we came up with around that and solutions we came up with for the problems, and then we'll end up with a Q&A. Whoops, whoa. Apologize here. Looks like I slipped forward about 100 slides. Okay. So my name is Michael Wojcikiewicz. I've been about 20 years in IT now. I'm a container solutions architect at CloudOps. I started off as a LAMP stack developer. This was when the P was with Perl, and I've worked with extensions Python, Java, Node.js. I worked at large enterprises, small startups throughout my career, and anything in between. And about 5-6 years ago, I moved into more of a DevOps role as opposed to developer. I've had 3 years production experience running the Google Kubernetes Engine and about 1 year's production experience with RKE. I'm also a Google Cloud Architect Certified Professional. So at CloudOps, we recognize that DevOps unicorns are special, but sometimes they too need help navigating ecosystems of projects and tools. So meet the CloudOps DevOps unicorn. Back in 2016, this is what the CNCF looked like. It's pretty simple. You can pick out most technologies. You can actually read it from the slide, and you could kind of figure out where to start if you needed to pick some technology. But fast forward to 2018, this is how the CNCF community has expanded. So this is awesome, but also adds many layers of complexity when you're trying to navigate the open source world. It's too many to even read on the slide. So this is where CloudOps can help. We are a Kubernetes certified service provider and a Kubernetes training partner. We provide consulting, training, and managed services for cloud native and DevOps practices and deployments. We can help with what we call a DPPA, which is a DevOps platform and practices assessment, where we look at your current state versus desired state and how to attain it. And we focus on the tech stack as well as the business value of the DevOps processes and application platform. We have a link right there. You can reach out. You can check out to see if you read more about this procedure, and reach out to us if you need any help, and we'll have some contact information at the end of the talk. So speaking of which, let's take a look at how we help the customer with their project. So the story so far, we started working with a large European hospitality client. They had many interconnected but independently developed and managed applications. So we migrated them from an AWS installation. We basically took a single one of their projects, migrated from AWS, which is a kind of vanilla 3-tier setup on virtual machines, into containers on the Google Kubernetes Engine on Google Kubernetes, Google Cloud Platform. We also were able to leverage several other GCP-specific resources, such as their object storage offerings, Cloud CDN, load balancers, the Google Container Registry, which is their version of Docker Registry, and Cloud SQL, which is their managed SQL offering. So here's what our architecture looked like when we migrated everything into Google Cloud Platform. So essentially, there's a service entry point, which was a hardware-based load balancer, which can both serve content from our CDN and can serve content from the actual application, which is running inside Kubernetes. I'm going to talk more detail about the other components here as we get to how we migrate these into an on-premises solution, but I just wanted to give a picture about how this looks. And so just to round it off, we have Redis for a session cache. We have Fluentd for a logging container. In Google Cloud Platform, Fluentd actually logs into their stack driver infrastructure, which is not a free offering as well. So what we decided to do was to basically put a custom Fluentd container that logged into a custom elk stack. So we completed this architecture about a year ago now. It was March 2018. We migrated the first component there. We kind of fleshed out all the, we did a lot of work around building automation, Terraform, Ansible, things like that. But then we discovered that since the client is European, it turned out about 3/4 of the customers are from the Russian Federation. And as such, there are Russian data laws, specifically 152F that requires any customer data relating to Russian customers to actually reside in Russia. And I think this also is the guaranteed kind of operation in case they get disconnected from the internet kind of thing. So we needed to find a provider that actually offered this available to us. So unfortunately, as of this writing, and unless this has changed in the last week or so, there's no hypercloud providers in Russia. So there's no Google Cloud Platform, there's no AWS, there's no Azure. So how was I to make this work? So we need an on-premises solution, and the first thing we needed to do was to find a premises. So we spent, and I wasn't personally involved with this, it was some of my team members. We have some Russian members in CloudOps, and we have a lot of contacts internationally, so we kind of used that to explore what was out there. I don't recall, I think we evaluated about 5 different providers. A lot of them, they varied greatly in quality, and a lot of them were also difficult to communicate with. Obviously, the English-Russian is an issue, but Gmail actually worked very well in that. And some of them, they just appeared too small, didn't have enough capacity for us to actually, that just became a non-starter. So we settled on a provider that was VMware-based, Cloud Director-based VMware provider. So they had a full 152F compliant environment. They had some Terraform plugins, but as we started experimenting with using our automations against that, due to the geographic distance between where I am in Canada and the API servers in Russia, we would get a ton of timeouts. You know, it wouldn't be able to determine the state. It was very, very unreliable. And as well, I think that there was an interaction between the version of VMware that they were using, the provider was using, and the version that the plugin supported. So our contacts at the provider, they also pointed us to a kind of a third-party Terraform provider. And this one actually worked a lot better, but one key thing that it was missing was being able to, when you Terraform a server, to specify how many CPU cores you wanted. So all that to say is that we weren't really reliably able to use a Terraform provider to automate a lot of this work, so we ended up having to actually do it the hard way. Whoops, I apologize, kind of sticking again. Sorry about that. All right. So since we couldn't use Terraform, we basically end up saying, okay, well, all of our hosts tend to work in two different flavors, one with a 40 gigabyte root disk, one with an 800 gigabyte root disk, and some of them may have extra local disks, local SSDs and things like that. So we decided, okay, let's just create a base image. Let's run our basic automations against it in terms of securing the image, securing the VM and things like that. And we'll use that to build out all of the infrastructure. It's a very manual process. But the more you got used to using the UI, the easier it became to do. But of course, the UI itself was kind of a funny story. It's an old version of Cloud Director. It's based on Flash. And best of all, they recommended to use Internet Explorer so all the UI features work. And then the next 4 points are just exclamation marks. You can imagine this was a lot of red flags for me running it, and it took me a long time to trust wanting to run their tool outside of anything other than kind of a dedicated VM with a browser with Flash on it. In the end, I've been running it for about a year now, and I haven't had any issues. But if my professional part of me, 20 years of experience, that just throws up a lot of red flags. So now we were able to provision all the VMs. We were able to get to the next step, which is which Kubernetes distribution do we actually put on here? So given we couldn't use any of the on-premises stuff, GKE, et cetera, we couldn't extend it. We had to go with something that was completely self-contained. So we looked at KubeSpray initially and KubeADM, and I've looked at these tools over the years as well. I'm not a huge fan. KubeSpray I find takes too long to install. It's a lot of like very complex configurations, complex to configure and to run. Most of all is once you actually install your Kubernetes clusters, operating them after the fact is very difficult with these tools, I find. Things like adding nodes, decommissioning nodes, upgrading components for Kubernetes. It was just very poor experience in my opinion. Until recently as well, I'm not sure if KubeADM has this or not. There was no ability to do multi-master setups, and I think that's something that's come in more recently. But of course, if you want to do a production-ready Kubernetes installation, you definitely want to have multi-master setup to be able to deal with having proper HA setup. So enter Rancher Kubernetes Engine. Rancher Kubernetes Engine to the rescue. In my opinion, it's the best custom Kubernetes installer to date, and I was convinced by this over several articles I read. One of them I linked here, which is Chick-fil-A wrote a little blog article how they ended up with that. And they kind of came to the same conclusions about KubeSpring, KubeADM, and RKE, and they decided to use it for the same reasons I did. So if you look at RKE, all it requires in order to be able to install your Kubernetes cluster is essentially just a physical, well, a VM or a box running Docker, preferably compatible with a Kubernetes version. You can actually also run non-compatible version, just at your own risk kind of thing with an override. SSH access with the passwordless keyed login, and that's pretty much it. So how do you actually operate Rancher Kubernetes Engine? A single configuration file, YAML file to specify your cluster configuration, a single Go binary that actually manages RKE, and that's pretty much it. So RKE itself has a set of commands that you run to operate, install, or decommission your cluster. So the basic one is RKE up, which sets up, initially connects all the SSH tunnels. It'll actually detect the state of your cluster. So if you're installing a new cluster, it'll actually start bootstrapping Kubernetes. So by doing this, it actually runs Kubernetes all inside Docker images. These Docker images come from Rancher itself. And so the API server, kubelet, all those things, they run in Docker itself. So it bootstraps a new cluster with your desired configuration in under 5 minutes. This is probably dependent on how large your cluster is. The cluster I was dealing with here was 3 masters, 4 worker nodes. So it installed in about 5 minutes. And this multi-master works out of the box. etcd is fully distributed. I chose 3 instead of, you want to do an odd multiple. And once you actually provision the cluster, the RKE binary exits, and it actually outputs kubeconfig client certificate that you can then use to interact with your cluster. So this is great. This takes about 5 minutes to customizing the config file. All that stuff is very easy to do. So let's take a look at a minimal RKE configuration file and kind of the highlights of what the things you have to set are. So at the very least, you need a single node, and you can define the role of the node. You can have it be a control plane, an etcd, which is a master, or you can have it be a worker, or you can have it to be any combination or all all of the above. Most important thing is you should have at least one, and you define all the other nodes you need in there. You need to define what your IP range is for pods and for services. So what your CIDR is for those. I tend to use, so since we're using a canal CNI in this case, the addresses you pick inside your cluster don't need to be routable outside of the cluster because they're, what do they call that, encapsulated packets. So you can just pick any range in there that's reasonable. I tend to pick something in the 1043, just tend to pick the same thing every time I use it, every time I define a range in here. And finally, the cluster DNS server, which is basically the service CIDR plus 11 addresses. These are kind of standard Kubernetes requirements. Other interesting things to note. So we're using the Canal plugin. As far as I know, right now, Canal I think is the main supported one. I haven't actually tried different ones with RKE, but there may be other implementations right now. I would imagine since they're all CNI, it's just a matter of just kind of trying it out and getting it to work. You enable RBAC. You tell it to ignore the Docker version. So this happened especially recently if you're any kind of in the system administration space. If you install Ubuntu 18 server. You cannot get Docker 17 for it, and I believe Docker 17 was the last certified version of Kubernetes. So you kind of have to install Docker 18, and you have to tell RKE just to ignore that it's a non-certified version. And then finally, you give it just a little name. So operating the Rancher Kubernetes Engine cluster is really simple. Lifecycle management, with the way the RKE binary works, is just super straightforward. If you want to add a new node, you simply go back to that YAML and you add another entry into the nodes list, and then you just run RKE up again, and it'll literally do what you think it will. So it'll add a new worker node, add a new control node, add a new etcd node. All of those things will just work. And it does it in a non-destructive way, kind of a rolling restart. If you decommission nodes, same thing, just remove them from the cluster YAML and run it again, and they get decommissioned. If you need to upgrade, so one of the things I didn't illustrate in the cluster YAML file here is there are a lot of other options that are not mentioned here, which is defining the versions of each Kubernetes component, so the version of the kubelet, the version of the API server, etc. I tend to use a default version that RKE supports, but if you run into a situation where a specific version is misbehaving, you can actually go in and override just that specific component. So let's say, for the sake of discussion, there's a bug in the kubelet, you need to grab the next version of the image. You can just go in and add that definition to cluster YAML, run RKE up, and it'll go install the new version of the kubelet for you. And then finally, if you want to do a complete upgrade of Kubernetes, upgrade say from 110 to 111 or 111 to 111 subversion, you just grab a new version of RKE and you just run RKE up, and it does it the way you would expect it. So when you're using a cloud provider like EKS or GKE or AKS, the Amazon, Google, Microsoft versions, the managed Kubernetes installations does really elegantly. They'll do, they do rolling restarts, rolling upgrades of all of them. The RKE binary attempts to do the same thing. It basically marks a node as tainted. It drains it from all work, performs the upgrade, untaints it, and then it gets back any workloads that it needs to run. And I noticed this is from running RKE since Kubernetes 1.9 up to now, which is 1.11.6. When you do upgrades of Kubernetes, always make sure you do the in-between updates. Don't do major updates. This can cause it's more unknown, and you can kind of screw up your installation that way. So it's much better to go with the in-between path. So 1.9 to 1.10 to 1.11. And I took an opportunity. I was at CloudCon this winter rather, KubeCon rather, and I talked to some RKE engineers, and I made sure that they gave me proper information for how all this stuff works. Whoops. This is frustrating. Okay. So it's not quite that simple. So RKE is really great for provisioning and operating an on-premises cluster, but it's not a complete solution in itself. Notably, what's missing is a storage provider, a container storage interface to enable persistent volumes and persistent volume claims, and load balancer. Some other missing features that we're using from GCP, like I mentioned, was the Google Container Registry, object storage, Cloud CDN, and Cloud SQL. So let's take a look at how we solve each of these problems in order. The quickest solution is how to pull images from the Google Container Registry. So one of the artifacts, so since the Docker images themselves that we run for this workload, they don't contain any customer data, there wasn't a legal need to store them in Russia. So we decided just to keep using our GCR repository. And the way you can actually pull from GCR is you add a special Docker secret, which contains, as you can see there, which contains a service account key from GCP. And you simply tell your deployment to use that pull secret when it pulls it. As long as that service account has been granted object store viewer permission inside your project that hosts your images, this will just work as expected. Cloud SQL on-prem, nothing really special to do here. This is just install MySQL. I was able to use the same Debian images we use for the Kubernetes cluster, minus Docker and things like that. And we had some CloudOps managed Ansible runbooks for configuring MySQL 5.7. So we essentially tend to do a standard deployment of a single master with 2 slaves. One is a real-time slave for doing reporting and failover in case there's an issue, and a delayed slave which ships bin logs instantly but doesn't apply them for 30 days. And this allows us to basically restore to a point in time, even if there's replicated corruption for up to 30 days. So fairly straightforward. This is not really cloud native or anything else like that. The object storage becomes more of an interesting problem. So when I started the solution, it was about a year ago, there wasn't really anything else that was production ready, specifically Rook or Ceph for on-premises that I was able to find. So we kind of, I spoke with a couple other consultants at CloudOps, and we decided, well, maybe we can use some off-the-shelf technology to make this work. So we decided to basically use GlusterFS to provide object storage-like functionality. This technology came out of Red Hat as well, I believe, and it's essentially replicated NFS for any of you that don't know it. But the idea here is that we could set up 2 Ingress nodes to front all traffic coming into the cluster. And by the way, I'll have a diagram about all this stuff a little bit later. But you said 2 Ingress nodes to serve content from the cluster itself, and also to serve content from GlusterFS. So it serves as a reverse proxy and a CD.
Michael, you still there?
Yeah, sorry, my headphones just turned off.
Okay, no worries.
Okay, I'm back. Proxy. Yeah, so each Ingress node basically has a dedicated device brick that stores about 100 gigs worth of data. Any data that's written to one node gets replicated to the other, and vice versa. And it kind of gives us a poor man's CDN to be able to serve any kind of CDN asset. So it doesn't matter if the person comes in on one Ingress node or the other Ingress node, they're gonna serve the same data. Then what we would do is we would take the GlusterFS volume, mount it inside each Kubernetes worker node, and this is where the application that we're running in Kubernetes could actually read and write assets for the CDN. And then finally, we just mount that volume that was mounted on the worker node into each pod as the host path volume. And then this allows the workload to basically write directly to GlusterFS. This works fairly well. You know, we're not dealing with millions of hits per day, things like that. So for our use case that we needed, it was more than adequate for kind of serving as an object storage and a CDN for our Russia installation. So let's talk about Redis. Depending on which flavor of Redis you use, it needs to use persistent volume claim for storing its data in a session cache. So storing its data. So the application uses Redis as a session cache, and initially, since we didn't have any persistent volume claimability, we temporarily just reconfigured the application to use SQL database as a session cache instead of Redis. But I decided in December, after having seen it in action at KubeCon, and Rook kind of graduated to an incubating project, to experiment with that and use that for the PVC, for the storage driver for Kubernetes. So it's really straightforward to use. I did spend a bunch of time playing with, you know, their quick start guide and their various documentation, things like that. I found the quickest way to get started reliably was simply to use the Helm repository, to use the Helm chart. So if you add the Helm repo to Rook directly and then you install it, that was the most reliable way to get it to work. So literally one command, it takes a couple of minutes to kind of bootstrap itself and it's up and running. So Rook itself is is essentially a plugin for Kubernetes. So it's a container storage interface driver. So it's loaded dynamically by Kubernetes, specifically the kubelet that runs on each worker node. So there's some extra configuration that was required for RKE to make this work, and it's essentially just providing 2 extra arguments into the cluster YAML file that points the kubelet to the location where Rook stores its CSI binaries and treats them as executable. So that's just what these couple of configuration parameters use. Once I added that to the cluster YAML, I was able to run RKE up again, and then that literally patched the live cluster. When it was all done, everything just automatically restarted and it worked. So up until this point, I'd seen all the RKE or the Rook components start up and kind of crash, and some of them weren't ready. Adding this, everything just worked as expected almost instantly. So now we have a Rook cluster. So Rook operator rather. So the Rook operator operates a Ceph cluster underneath the hook. So we need it underneath the hood. So we needed to now configure Ceph itself. So what I actually did was I cloned the Rook Git repository, and there's some great example configurations to kind of get you started there. So this talk we're talking about all the vanilla examples, but there's a lot more obviously, right? So what we decided to say was each worker node we're going to have a dedicated 100 gig SSD brick, and we're just going to tell Ceph to only use that brick for persistent data. So that's where you see this device filter SDB in there. That was the only modification I had to make to their vanilla configurations to just ensure that that was the case. Then I ran kubectl create on it, and then that created a Ceph cluster as a result. So now Rook operates a Ceph cluster with the designated storage bricks, but finally to actually use those storage bricks, we have to create a storage class, which is a Kubernetes resource, to actually tell installations that this is where you're going to get your storage from, rather than whatever the default storage is, which in case of RKE just does nothing. So once again, there's a storage class YAML file from the Rook source tree, and I use that verbatim to create the storage class. So that'll actually create a replica pool and a Ceph block pool and a storage class that uses that Ceph block pool. So it's kind of a couple of levels of abstraction here. You have Rook controls Ceph, and Ceph creates blocks, and blocks tied to storage classes. For the purpose of this example, like I said, I'm using vanilla configurations. So here you'll see very simple configs for Ceph block pool replicated size 1. This just tells it to use an object storage device replicated exactly once. Depending on your workload, depending on your use cases, depending on how resilient you want your data to be, how performant you want it to be, there's a ton of options in Ceph for optimizing those types of things, but it's beyond the scope of this talk. So now we have a storage class called Rook Ceph block, and we can install Redis and just tell it to use that storage class. So once again, I'm a fan of using Helm. It's just very simple to install a lot of complicated applications, and most of them, if they're set up properly, will actually have overrides for these types of settings. So here you'll see an example where I'm installing a stable Redis version, and I'm telling the master and the slave to use a persistent storage class of Rook Ceph block. So when you run this, it'll actually request the storage from Ceph and from Rook and use it. You can also specify how large you want that to be. I think the default in this case is 5 gigs or something like that. I guess if you tend to use Redis as a session cache or something like that, you don't need you don't generally need larger blocks, but if you do, it's all settable using the Helm chart. Once again, sticky keys. I apologize, this is really frustrating. Okay. So we talked about PVC. Now how about logging? So I mentioned before Fluentd, and Fluentd is also used when you run in Google Kubernetes Engine, and it's basically become the de facto logging agent for Kubernetes. It's another CNCF project. So it's much needed in the logging space. Currently, I believe it's implemented in Ruby, and in Ruby, there's a non-dynamic language agent in development called Fluent Bit, which I think is Rust or something like that. I don't think all the features are there yet, and no one's really using it in production, so I'll talk about the Ruby version. Has many input plugins, many output plugins, which is why it's really so great, and it's been under active development for a while. What was a bit frustrating, I think, in the last year, that maybe they got a lot of pickup in adoption. When they went from the 0 version to the 1 version to the 1.1 to the 1.2, I continuously got strange kind of bugs that I had to deal with going in and fix when I. This is another one of those best practices. Always pin the version numbers of stuff you're using. What I ended up using in this case was just like a name tag called Elasticsearch, and that would, if the node rebooted or if the Fluentd pod restarted, I would just get the new version, and the new version would break. So this is kind of I should have known better and pinned it right from the start, but these are kind of things to watch out for when you're dealing with on-premises installations as well. So what do we need from our actual logging? We need a comprehensive Kubernetes monitoring configuration, so pull out getting visibility into all the Kubernetes components themselves. We want to have some sort of sane application log parsing out of the box. So some of our applications were Java or Node.js. They produce JSON structures in their logs. So we needed the logging solution in this case to be able to unpack those, put them in Elasticsearch, and make them searchable based on those types of attributes. So the best Fluentd image, as I mentioned, is currently this one called v1.1.3, Debian Elasticsearch. So it's based on a Debian base image, and it has output syncs to Elasticsearch, which is self-explanatory. But I found it to be the most stable and easiest to use currently. So 1.2.x had a dependency on a non-standard Debian library, something with systemd, I think. So when I was running that, the latest version by default, the Fluentd agent was causing massive load on my cluster. So I Googled for it, and I found out that was the case. I ended up kind of just reverting to the last major version, which is 1.1.3. But the out-of-the-box JSON and JSON parting didn't seem to work in this version. And I actually, I got a chance, our booth at KubeCon was right next to the Fluentd booth, so I went and I picked on a couple of the engineers. They might have thought I came up as a bit of a lunatic because I wanted them to fix this in their images, because nothing ever seemed to have come of it. But I tried to make them understand what the problem was, and like it'd be very nice if they would provide a bundle, an image that just does everything out of the box without having to do this kind of custom patching and adding things to my nodes and things like that. I'm sure they're going to get better with time. It was just, I had just been dealing with these version changes, and they caused frustrations every time there was a major one. And then finally, we needed a way to designate certain attributes in the JSON logging from our application as numeric. So this is important when you're sending your logs into Elasticsearch. It's more efficient to search for those types, strings versus numbers. It's more efficient if it knows what type of data you're searching for. So this is essentially what we started with. So inside the Fluentd image, there's a Kubernetes conf. We just pulled that out of the image, and we added this bit of piece to it, which is what I found from extensive Googling and kind of re-enabling the JSON and JSON parsing. So essentially what this configuration says, for every line that comes in from the Docker container of your application, if it's a JSON, if it's parsable in JSON, parse it in JSON. And additionally to that, any attributes called elapsed time, treat it as a float, status code, treat it as an integer, byte sent, treat it as an integer. And then you just simply take that entire file, put its content into a config map, and you can use it from the Fluentd agent. I would say there's a bit of a ramp-up time learning how Fluentd works properly and kind of grokking how the configurations work, but it just kind of comes with time, and all of a sudden it makes sense one day. So you simply take the contents of that file, stick it into a config map, and then you can mount the config map into the Fluentd pod itself. So some of you may not know this. When you mount files into a pod, it can come from a config map. It can come from a physical volume, but you can mount a specific file into a path. Whereas most people, I think the most examples when you look at how to do this with Kubernetes, they only show how to mount an entire directory into a pod. They don't show how to do a single file. So all that to say is the example I have here at the bottom, where you mentioned subpath kubernetes.conf, that tells Kubernetes to only mount in that one single file and not anything else in that directory. What would happen otherwise is Fluentd would start up, it would see that there's no other files other than Kubernetes conf, and it would crash. This way, we're providing a single override for Kubernetes conf, and Fluentd just works happily ever after. So you do want to do a couple of modifications to Fluentd when you start it up. So the image comes with an example deployment YAML file where it has a set of environment variables you can override when you start Fluentd. Most important one I think there is a logstash prefix. So when Fluentd sends data from this particular agent into its Elasticsearch infrastructure, it'll prefix the index with this value here. So one example you have, and this is something I actually use for my client, is we have kind of a shared logging Kubernetes cluster that receives Fluentd data from other clusters. Each other cluster has its own value for this. So it's better indexed in Elasticsearch and is better performant in Elasticsearch. And then by default, this will roll once a day. I think Fluentd will actually add a date YMD to the index, and that means it just rolls every day, so you kind of don't have to worry as much about optimizing performances and indexes and things like that. One thing I probably won't talk about here is if any of you have worked with Elk, there's a component called a curator, which can expire old data. It's beyond the talk of this conversation, but I just wanted to mention it because one day, if you're just logging for a year, you may very well run out of logging space if you don't use that kind of component. So I mentioned Elk, right? So initially we had a separated dedicated Elk cluster. So we'd run 3 virtual machines for HA, running a Elasticsearch cluster. These were running Ansible or playbooks that CloudOps had developed. But we found that it's 3 nodes just for HA, but it was very underutilized, over-provisioned. And I was really wondering, well, do we really need to have like kind of a dedicated cluster like this? Could we not just add that compute that the Elk cluster used to the Kubernetes cluster and then run Elk inside Kubernetes? Well, turns out we could. There's a Helm chart, stable/elastic stack that lets you do just that. So we wiped the Elk cluster. We put fresh Debian 9 images, just like the other worker nodes. I added those 3 worker nodes to RKE's cluster YAML file, and then I ran RKE up, and a couple minutes later, we had all those former Elk dedicated worker nodes running as Kubernetes worker nodes inside Kubernetes. So now to actually install the Elk chart, we wanted to give it a larger persistence. So in this case, we gave it 50 gigs storage, and we told it to use the Rook storage class that we had created earlier. I mentioned before you can, so this chart is actually kind of a meta chart that's made up of all the various Elastic Stack charts. So there's a chart for Kibana, chart for Elasticsearch, chart for Logstash, etc. You can set all those configurations inside the Helm install command, and you can enable and disable them. So I didn't include them here. I tend to disable Logstash. Logstash is a great front end for something that doesn't talk directly to Elasticsearch, but in our case, our Fluentd agent syncs directly to Elasticsearch. So we didn't actually need a front end for Logstash, so we don't actually install that. And then as well, the curator, you can enable the curator here, and then you have to go in and configure how long how often it should expire old data from. So unfortunately, when you run and install the Helm chart for Elk, and it's odd because I think the bug is still there. I had to fix it last week as well. There's a weird bug with Kibana when you install it, which it has a hard-coded value for where it expects to find the Elasticsearch endpoint. So first time you install it, you have to fix this. It seems to always be the case. I've been telling myself every week that one of these days I'll get some time to fix it and send a PR. I just haven't had the time to actually do it. But it's a pretty easy fix. I just kind of keep it in mind. You just edit the deployment after you've installed it with Helm, and you point it to, you can look up the kubectl service for it. So in this case, if you call the installation Elk, the service is called elk-elasticsearch-client. So that now plugs in Kibana to the Elasticsearch backend, and then you have to tell Fluentd just to point the Fluentd agent to the Elasticsearch host, which is also the same thing as the Elasticsearch client. So you literally put the same value inside your Fluentd configuration. Now for actually accessing Elk, there's a couple ways to do it. If you don't really want to deal with setting up a separate Ingress, securing or things like that, the simplest one is to use kubectl port forward and just set up a local tunnel into the Kibana front end. You could also set it up, expose it as a node port, and add it to an nginx front end. Or what I'm going to show quickly is just adding it as a Kubernetes Ingress resource with a username and password to secure it, and let's make that kind of the most reliable installation. So RKE, when you install it, it does install the nginx Ingress controller as the default Ingress controller, given it doesn't have any on-cloud controller features. So you have to use annotation to tell Kubernetes to use the nginx controller, and you have to secure the service if necessary. So a quick way to do that is you just run HT password, and you give it a username and a password there, and it'll give you a string that you then can give to nginx, which it'll use to actually secure your site. So here's an example: is I get that string, I create a secret from it, and then I'll show you how I actually use it. So you create a secret which contains the auth string, and then you finally have to create a secret to contain the SSL certificate. In this case, something to be aware of, and if any of you have worked with Ingress already, you'll know that the certificate there has to contain the entire certificate authority chain as well, and has to be in a certain order. And I find certain SSL providers, they'll send you those out of order, like they'll send you in reverse, or they'll send you, like, it's a bit weird sometimes, so just take extra care to make sure that you create the right certificates in the right order, and then you won't get any errors. So here's what you would actually, the Ingress resource you would create to actually use this. So the first thing is you create an annotation to tell to use the nginx Ingress class. You give some meta information for nginx to, when it asks for authentication for someone actually using Kibana, and you basically tell it I'm using an auth type basic, and to pull that auth from the secret that we created in the previous slide. And it's basically straightforward Ingress rules here. We say, okay, I have elk.myapp.domain. It simply forwards to my Kibana backend, and it's secured by this TLS secret. One other thing I wanted to mention, because I think this is pretty neat, especially coming from GKE, the GKE Ingress controller doesn't do automatic HTTP, HTTPS redirection, which is really, really, really frustrating, but nginx controller does. So there's no extra annotations you need to kind of disable the HTTPS redirect. It'll just do it automatically with this type of configuration, which is nice. So for whatever reason, the Russian cloud provider does not have the ability to assign a hardware load balancer to front the infrastructure, which is a bit frustrating. So we decided to basically just do a bit of a poor man's load balancer, which is 2 nginx Ingress nodes, so the same 2 I've been talking about all along. Round robin DNS that resolves each node's IP. It's kind of a poor man's load balancer. So we basically have a reverse proxy for all the Kubernetes traffic, and then it serves all the CDN traffic on another path. Most important to note is the SSL termination is not done by the nginx ingresses. They're actually done by the Ingress controller in Kubernetes.
You there, Michael?
Yeah,
Sorry.
Okay, we're almost done.
No, it's all good.
So here's how the final architecture actually looked at when we moved it into Russia. We still have our image repository in the Google Cloud Platform. You see the DNS is used to load balance between two front ends. You see how the Gluster FS server serves the CDN content. You see we're running Elk inside the Kubernetes cluster, running the Fluentd, we're running Rook Ceph, we're running our Ceph cache, and we have our MySQL servers outside. I don't know why those MySQL icons are working, but I'll probably fix that.
Sorry, Michael, I can't hear you. I don't know if it's everybody, but I definitely can't hear you.
Can you hear me now?
Yes.
Okay. That's odd. So did you hear nothing for like the last minute?
No, I heard like kind of like garbled.
Okay. Well, this is just to illustrate this kind of the end state and see where everything lives and how everything's made up of. We also use Datadog and Instana as our monitoring agents. So not represented here, they're actually a Datadog container also running as well. These are pretty neat. They offer extra insight into running workloads if you're running JVM or something like that. Oh, apologize. And that's the end of that. Happy unicorns and rainbows. I want to say special thanks to Julia Simon, Senior Product Marketing Manager at CloudOps, and Emma DeAngelis, freelance artist. They made my presentation, which used to look like chicken scratch, actually look professional. And then just some more information, CloudOps, you can see information. You can reach us at www.cloudops.com or send us email at info@cloudops, and there's Rook and RKE and Fluentd. Okay, over to you, Priyanka.
Wonderful. Well, thank you so much for that great presentation. I appreciated the detail. And now we have some time for questions. So let me look into our Q&A box. So there's one open question here. Well, two now. Good. Yeah, audience, keep popping in your questions. The more, the merrier. So I'll start with the first one. Walid Shari asks, if my worker nodes all have access to NetApp/NFS, should I still consider different storage such as Ceph or Rook, or we can just work with host volumes over NFS? What do you think, Michael?
That's a great question. If there's no extra cost for you to work in that environment, I think that's a great option for now. I say this because while I've been working with Rook for a couple of months now, 2 or 3 months, I feel it's production ready, but like it's not battle hardened yet. So you might, I'd say if it's very simple use cases, use Rook. If you have kind of complicated setups, you can use your net filer to achieve those types of things. I hope that kind of helps a little bit. It's going to be very specific on the type of workload and the type of like the type of reliability you need. But I would say it would probably, it's the right time to experiment with using Rook. I think Rook is a fine strategic choice moving forward. And I know that they're going to get there this year with being fully kind of battle hardened in production. But for your specific use case, I would say experiment with it first before you start replacing the net filer stuff. Thanks.
Great. So related to Walid's question, John Dilly, I hope I said that right, has a question. There are some others ahead of the queue, but since it's related, I'm going with this first and we have plenty of time. So he says, why did you choose Rook for Redis PVC, not the Gluster FS you already had?
So there's a provisioning agent for Gluster FS called Heketi, and I had experience with that through another project I was working on, and it is very, very, very fragile way of orchestrating Gluster FS. So essentially, the problem with Gluster FS, I think it's a bit of it's a fine replacement for NFS if that's all you're using it for, but for provisioning dynamic storage in Kubernetes, it's not so good. Ceph is, in my opinion, Ceph is essentially like an iteration is not the right word, but a replacement for that type of system, designed to be more cloud native, designed to operate inside Kubernetes and things like that.
So along those lines, Jean-Christophe Cogno, again, sorry folks, I'm probably butchering everybody's name. Can you talk about using local storage in Kubernetes versus Ceph?
I mean, Ceph just gives you the ability to, if your pod stops on one worker node and starts on another, it has access to all the data, right? The standard behavior you'd expect from persistent volume, right? Whereas local data, if it moves across nodes, that's not going to work, right? Obviously, you can use things like affinities and selectors to kind of pin workloads to certain locations. And there may be use cases where the great thing about local storage is that it's very performant. You're just writing directly to a local disk, could be SSD, what have you. Whereas Ceph, you're inherently networked, and you can throw in very high performant network sort of hardware and things like that, but you're probably not ever going to get the kind of raw throughput as you would get in that. So it depends heavily on your use, on the type of data writes you're doing, I would say.
Great, thank you. So then there's a question that's sort of more meta. John Dilly asks, regarding RKE, did you also look at Salt? How would you compare RKE and Salt?
I have not heard of Salt before. I can't really say anything about that, sorry, but I will, now that it's on my radar, I'm going to read up on it.
Yep, totally. Yeah, John, feel free to post a link here if you have it. I've never heard of Salt either. Okay, next question. Oh, so Walid says, Salt is a configuration management tool, not Kubernetes distro.
So it almost sounds like that's more like a comparing to, say, KubeSpray, which is Ansible-based Kubernetes installer. Kind of sounds similar. If that's the case, I would argue those types of installers kind of function on the wrong paradigm. I think they're what I really like about RKE, it's a single binary. There's a single path for everything. It has more integrated control over what it's doing, as opposed to I don't want to talk crap about it, but basically Ansible scripts and things like that. that's just my completely uninformed opinion about what I know about Salt.
Yep, and some people have added in info about Salt. It's similar to Ansible and Puppet, and John added a link. So perhaps for this specific one, you can take a look afterwards, Michael.
Yeah,
And
so maybe just to add to that again, the way that these types of installers work, they're over an SSH connection, they're using Python, I'm assuming in this case, or what have you, right? But they actually perform direct installations on the server. What's really, really cool about RK is that everything is Docker images. So there's a lot less, everything is completely self-contained in the RK installation. You don't really have to worry about distribution, flavor differences, things like that on your physical VM. So yet more reasons why I think RK is a much better choice in that case.
Lovely. Okay, so another question from Sasha Saitman. Where do you keep all the config files, configuration?
So good question. So since I'm in DevOps, I do store everything in Git source repositories, but our CloudOps as a company, we're DevOps shop. We're not actually doing the development of the products that I've talked about. So in a previous life, when I was working, when I was doing everything DevOps and development, I tend to keep the source code together. Now we kind of have a clear separate repository for the application source code, and we have a separate repository for the DevOps code. But yeah, I make an RK subdirectory that contain all the configurations. I have special SSH configurations because of how I need to access the physical nodes, things like that. But yeah, I would group them together if I could, but I can't, so I keep it separate like that. But I still keep it organized per project.
Very reasonable.
No, one thing to add to that, if there are, if you're putting in, say, SSH keys or anything sensitive related, obviously be careful about storing that stuff in Git.
Mm-hmm. Cool. Walid Shari asks, should we go with CRE-O, or is Docker, or are Docker containers just fine? I know Rancher can support CRI-O, correct? And why not go with Docker EE?
I don't really have an opinion on that. I think I used the vanilla configuration, which is just using Docker, I think through run C. Yeah, I started with Kubernetes in the early days where everything was Docker, so I'm just maybe I'm just biased towards sticking with that, honestly.
Like personal preference.
Yeah.
Cool.
I mean, there are technical differences, but I haven't come across one that matters to me.
Fair enough. Fair enough. Okay, and again, Walid asks, does RKE use SE Linux? I don't know these things. SE Linux or AppArmor for security and isolation?
No, so it runs, like I said, it's literally running Docker containers on a physical host. So if that host, if you want to run SE Linux on that host, you can surely do that, right? Or whatever flavor. Other than that, it uses standard Kubernetes and Docker security, like everything that every kind of Kubernetes stack has in isolation. Really nothing special. I'm not aware of any kind of direct integration with SE Linux, is what I was trying to say.
Cool. All right. So those were the questions. Oh, wait, there's something in chat. Let's see here. Okay. So Alexei Smirnov says, is it possible to customize the Fluent parser for specific pods/deployments, or is it local config only? Can it be configured to properly parse multi-line/stack traces?
I know it can do multi-line. I've seen examples when I was hunting for bugs. For the specific pod deployment, so let's see if I can find the slide again. If you recall the slide where I had the Kubernetes configuration, the very first thing you specify is kind of a path for where Fluent can find the logs. And that's typically var, log, container, and then just a bunch of wildcards in there, right? I think in theory, those wildcards, so they resolve to like a UUID, but I think they also resolve to like a pod name. I'm like 80% sure this is the case. I'm just trying to answer the best that I can. But in that case, you might be able to provide a path to I would say more likely like a stateful set or a deployment to basically apply that filter only on that particular parser. I believe also the configuration, you can when you specify like a filter or parser for Fluentd, you can tell it to look for certain things, and if they're not there, it's just not going to apply it, right? So in your use case, it would be specific because it wouldn't be parsing anything else, if that makes sense. Yep.
Cool. One more question here from Sasha. What is the volume? What is the log volume in GB per day for Fluentd processes for you? Was high volume a reason to go with Fluentd, or was it just a nice centralized solution for logging?
Mostly nice centralized solution for logging. It's just that the ease of use, getting it configured and getting it running. We don't do a lot of heavy, like gigabytes per day of logging. It's just, it was a nice way for us to route all the stuff into Elk and everything like that. Yeah, I will say having, if you do have like heavy log writing requirements, there's definitely some caveats to the stuff that I've shown. So running Elk inside Kubernetes, you're dealing with the performance of the underlying CSI and things like that. So that may not be, if you have a certain number of throughput requirements for logging, that may not be sufficient. But just specifically ease of use, and it just happened to fit in my use case.
Wonderful. Cool. All right. Well, audience, do you have any more questions? We have a couple of minutes. So I see, okay, there's one more. From Alexei, do you think it's a good practice to have separate EFL or ELK for cluster logging and a separate one for application logging or is that unnecessary complexity for single company clusters?
So assuming performance, not necessarily an issue, right? I like having everything in one spot because you can do queries that look at, or dashboards that look at multiple, you can look at your application performance and your VM performance in the same spot as opposed to separating, and also like the Kubernetes related state. I like that, but depending on like how much logging you're doing, and if it's have multiple sources, that may be something that you need to kind of shard on. In my experience, the way I tend to shard on environments. So I'll have a prod cluster, I'll have a staging cluster, I'll have QA cluster, etc. But I tend to just using different indexes that go into Elasticsearch to keep it performant and just log it that way, as opposed to having separate clusters for system and for apps. That's just been the way that I've fortunately had to work. But if you're dealing with very large enterprise infrastructure or something like that, that might be a use case. That might not be something you can do.
Sweet. Okay. So we have 2 minutes left, so time for one more question or comment. I always welcome comments because people might have something to add to the story. So let's see here. Q&A has something. Just Arun Agara asks, just curious, do you see any difference between Splunk versus Datadog for metrics besides the cost? Ooh, good question. I like this one.
So I haven't seen Splunk used in about 5-6 years. So my opinion is based on what I knew it was back at that point in time, which was a very expensive, great logging infrastructure, but it was very expensive. Datadog, it seems like, so actually, like I said, maybe that's come down in price. But what I know about Datadog is that they have a lot of plugins, a lot of features that makes it very intelligent in what it can actually detect in your system that you don't have to configure out of the box. Like that kind of stuff I found really, really powerful, if I didn't have to spend too much brain power to actually configure them. Like I said, I can't really talk about how far Splunk has come because I'm not sure how their agent works today.
Very reasonable. Well, all right. Well, that's all the time we have today for our questions and comments. And thank you, audience, for joining in, sharing such good questions, sharing your thoughts. I think this is the whole point of the CNCF webinars, for us to all exchange knowledge. You did amazing, Michael. We all learned a lot. Thank you, everyone, for joining today. The webinar recording and slides will be online later. And we look forward to seeing you at a future CNCF webinar. Goodbye and have a good day or evening. Bye.
Thanks, everyone. Bye.